Hi there. In this short lesson, we're going to look at rearranging a formula. First off, if you are very comfortable with rearranging formulas and you understand how to cross multiply or move things out of the denominator or to the other side and isolate a variable, then you can skip this lesson. But if you don't feel comfortable rearranging formulas, then this lesson is for you. First thing we need to mention is that when we're using this density formula, which involves three variables, density, mass, and volume, it's very important that we know two of those three variables before we can solve for anything. So for example, if I'm solving for density, I must know the mass and I must know the volume. Otherwise, I can't calculate an answer. So let's go ahead and we're going to solve for mass. Rearrange this formula to solve for mass if I was given the values for density and the value for volume. And then afterwards I'm going to solve for volume, isolate volume in this formula. So let's start first of all by isolating mass on its own. So here I'm looking for mass, and I want to think about how I can isolate that on one side of the equal sign with nothing else attached to it. And the first thing I'm going to mention is that we have this formula D is equal to mass over volume, and the density on the left hand side of the equal sign could also be written as D over 1. And I'm going to do that because it's going to be useful for us when we think about cross multiplication here. So generally we would never write something over 1 because it's just not necessarily any number or value divided by 1 is that same number, the same value. So that's not some standard notation for us to put it over 1, but it is helpful in terms of thinking about what we have here. So the first thing I want to do is isolate mass, and I need to get rid of this volume that's on the bottom because right now it's dividing mass. Mass is being divided by volume. So one way that I can remove the volume from the denominator is to multiply the right hand side by volume. If I do this, I'm going to undo the fact that mass is being divided by volume. In other words, I'm going to cancel the volume on the right hand side. But in any equation, anything I do to the right hand side, I also have to do to the left hand side. So if I multiply by volume on the right to get rid of volume in the denominator, I need to do the same thing to the left. But notice on the left hand side, it's not going to cancel because I don't have volume in the denominator. So what I'm left with, if I rewrite this down below, is volume times density is equal to mass. I've just dropped that 1 because it's not necessary to have right now. So I've cleaned it up a bit. Well, there's my answer. There's my formula rearranged for mass. I can simply switch these around so that my mass is on the left and my dV is on the right. And again, it doesn't matter whether you write volume times density or density times volume. Doesn't matter the order. Okay, so there I've cleaned that formula up. Mass is equal to volume times density or density times volume. I'm going to approach this exact same question in a slightly different way using cross multiplication. So let's step back 1 minute. Just going to clean this up. So again, I have my formula D equals M over V. And this time I'm going to again get rid of that volume on the bottom. I'm solving for mass, but I'm going to use the method of cross multiplication. Anytime you need to move something out of the denominator, which is the bottom of a fraction, you can cross multiply, and cross multiplication means multiplying the numerator on one side by the denominator on the other side of the equal sign. And cross multiplication will allow me to bring up anything that's in the denominator. So in this case here, I could cross multiply both sides, okay, so that there's nothing left in the denominator. Here I would have D times V on the left, okay, and on the right hand side I would have my mass times 1. And if I were to clean that up a little bit, I realize that mass times 1 is simply just mass, so I can get rid of that 1. And again, there's my same formula for mass derived again. I'm going to flip them over so that my mass is isolated on the left, and I'm going to have my density and my volume on the right. As you get more comfortable with cross multiplication, you will realize that when you're cross multiplying here, okay, you're really essentially just moving up any value in the denominator to the other side of the equal sign so that it is now in the numerator. So this is just a shortcut method. Really what we're doing is multiplying each side by volume, but you'll notice that a fast and quick and easy way in your mind to rearrange a formula is to see that anything on the denominator can be moved into the numerator, but it needs to come over to the other side. So there I can do that, and I could move this 1 over in the same way. And now I have mass is equal to density times volume. You can do this for any formula, particularly complex formulas where you have a lot of different variables in the denominator. If you're trying to isolate one variable, one strategy is to cross multiply, get everything out of the denominator, and then find the variable you want to isolate. And if there's anything attached to it, you can simply, for example, the 1 here, you can simply then divide by that or move it back over to the other side, okay, in the denominator. So that's a great strategy for if you're having difficulty rearranging a more complicated formula. Let's look, using these same strategies, let's look now at how to isolate volume in the same formula. So I better put my formula back the way it was. Mass over volume is equal to density. This time I want to solve for volume. Oops. Volume. Volume is equal to what? Okay. Again, I have volume in the denominator on the right hand side. I need to get it isolated, but I also need to get it up into the numerator. Okay. So there's a couple of different ways I could do this. The most straightforward strategy is to do what I just did in my previous step and cross multiply. So let's get it out of the denominator by cross multiplying. Okay, I multiply such that I get volume now in the numerator. So I have volume times density is equal to mass, but I'm not quite done. I see that I need to isolate that volume, so density is currently being multiplied by volume the way I have my formula set up. I need to divide both sides by density, and I see that my density will cancel on the left, so that I'm now left with volume is equal to mass over density. And there is my answer. Okay, volume is equal to mass over density. We could derive that exact same formula in a couple of other ways as we get more comfortable with rearranging formulas. So another kind of trick to rearranging formulas is to recognize that whenever you have a statement like this and you have something in the numerator and something in the denominator, it's equally true, okay, to simply flip everything. So in the same way that whatever we do to one side we can do to the other side, or we must do to the other side, we could also say that if I were to flip or reverse my my numerator and my denominator on one side, I could do the very same thing on the other side. Okay, so that's another just quick way to get the volume into the numerator. I can simply just flip both sides, okay, or take the reciprocal. If I were to use the math term, take the reciprocal of both sides such that now I have volume over mass is equal to 1 over density. And then again, I need to get my mass out of there, so I can cross multiply it by moving it up into the numerator but on the other side. And I really don't need to have the 1 in my formula because I know that anything multiplied by 1 is just that value. So mass times 1 is just mass, and there I have volume is equal to mass over density. If you want to write that out so that the volume is on the left hand side of the equal sign, the way we generally write a statement, you just simply move them over. So that volume can just come over here, and everything on the right can just, or on the left, can just be flipped over to the right. And we can get rid of that fraction. We don't really need it. Okay, so a couple of just things to note then, to do a quick recap. If ever you want to get things out of the denominator, you can simply move them up into the numerator, but they have to go to the other side, right? You can cross multiply anything to get it out of the denominator. Okay, and then if you want to move something to the other side and isolate it, you have to do the opposite of what's being done to it. So here, for example, if I want to get my original formula back and I want to get D on its own, my volume is attached to the D, it's being multiplied. I need to undo that by dividing both sides by V, or I can simply say, if I want to move it to the other side, okay, if it's in the numerator right now, it can go to the other side, but it needs to go back down to the denominator. Okay, so when you're thinking about formulas, if you were to put a big X through the equal sign like this, okay, any of these variables can travel across to the other side of the equal sign, so long as they can never travel directly across. So this M can never go over here like this when I'm rearranging a formula, okay, but I can move it down into the denominator. Similarly, my volume could come up, but if I wanted to move my volume across, it's got to come up into the numerator. And my density can come over to the right hand side as well, but it's got to go across, opposite, into the denominator. So in other words, you can kind of think of them like if you put a cross to the equal sign, your variables can travel to the other side as long as they travel along those dotted lines. I hope this is helpful in helping you rearrange formulas. This is good practice for you, and notice that you don't need to memorize 3 different formulas for density. You just need to know density equals mass over volume, and then using your tricks and your strategies, you can rearrange any formula, including this one, to solve for the other 2 variables. Best of luck!